Hello YouTubers and fellow hams. Well, this video is about splatter, and I need to say right up front, this is not going to be a finger pointing video or a finger wagging video at specific operators. I'm not going to go and say, look at this guy, and give his call sign and all. No, I'm not going to do that. What I'm going to talk about is splatter, what it is, why it's bad, a couple of common causes of splatter, and what you can do using a tool that's built into most every radio to assure that your signal is not going to be splattering. So I guess first up we need to talk about what splatter is and why it's bad. Well, to show you what splatter is, I'm going to use my SDR software because we get a nice visual representation of things. The waterfall shows signals going back in time, right, a few seconds. And what we see here on 40 meters is we see two single sideband signals that are quite clear, one here and one here. Can you tell which one is splattering? Splatter is when your transmitter is generating energy outside of where your filter should limit it, or where your modulator should be suppressing it. So this is a good example of a very clean single sideband transmission over here. This is lower sideband. So the carrier point would be right here at 7255. Ignore this little line. This is actually coincidentally a little bit of interference from my solar panel charger, which is exactly where this guy's carrier would normally be, but the carrier is not there. It's suppressed. And going down in frequency, this is the lower sideband. Now, if we look here, the carrier point's at 7255 kilohertz. And if we go out here to where his energy is stopping, right here, that is 252.3. So that's about 2.3 kilohertz wide. That's just about exactly right. This is a very clean signal. The audio energy that he's casting out is staying within the 2.3 kilohertz. There's no energy, maybe tiny little bitty fragments, but you'll always have a little bit there. But he's not throwing any energy out here into the upper sideband at all. And this is a good, clean, single sideband transmission. Now, if we listen to it, and we'll do that in a moment, we'll go ahead and activate the receiver and we'll listen to some signals. His voice will be very clear and very easy to understand, almost like he's standing in front of you and talking to you. Over here, we have a very ugly, splattery signal. Now, the carrier point would be right about here, so 7278. 7278 would be about where their carrier is. And over here we can see where his filter is. You can sort of see where most of the energy stops right here, and that is at 7275. So that's 3 kilohertz. He's 3 kilohertz wide, which is okay. You can go up to about 3 kilohertz as long as your signal is clean. But you can see these sparks of noise and garbage that he's throwing out. And look at this one. This is coming way out here, all the way to 769, almost. Well, what was this, 728? Yeah, 728, almost out to 629. He's throwing out, well, actually, yeah, almost out to 7629 or 769. So he's throwing energy out at the extreme, almost 10 kilohertz away. Wow. And there's a weak transmission here, right next door, and this guy would, if he was close enough, or a little bit louder here, he would probably be hearing a little sound from this dude. But this is what splatter looks like. This guy's transmitter or his amplifier or his drive to his amplifier, something is wrong here, and he is throwing energy way out beyond where he should be. But even worse, if we go up here to the upper sideband where he should be doing nothing, he should not be casting any energy out at all into the upper sideband. But he is casting energy out here. Let's go out to where it just sort of falls off. 7282. So 78 to 82, that's 4 kilohertz. He's throwing garbage out 4 kilohertz into the upper sideband where he should be producing no energy. This is what splatter looks like, and it is bad because it interferes, for one thing. If there was another QSO going on right here, the noise from this guy would make it hard to understand. He's also occupying in total 7272 to 82. He's occupying 10 kilohertz of spectrum space where he should only be occupying 3. So that's why splatter is bad. It'll interfere with stations. It'll cause you to make unusable more of a chunk of spectrum than you should be occupying. It's just inconsiderate. It's not good. Plus, it degrades the quality of your voice. We'll go ahead and I'm going to start the receiver. Let me turn the volume down initially. Okay, and we'll look for that clean transmission again. I'm almost afraid to play audio from... Well, here's another clean one here. Let's look at this one. Okay, so this is a nice, clean, single sideband signal. Let's see what he sounds like.
Maybe not. Good morning, everybody. Yeah, we're working in the background here. Putting the audio amplifier together that my son has.
So as you could hear, his voice is nice and clear, easy to understand. Now let's go and listen to a splattery signal as soon as I find a good one.
Being required, you only have to have an interest and a nice friendly attitude to come in and say hi. So come on in.
So if you were listening to his voice there, you could still understand what he was saying, but it sounded like he had the microphone like right up against his mouth and he was just shouting into it. It was kind of overdriven and there was a lot of that. No, there's another example. Well, it adds distortion to the voice. And in the extreme cases, it can make it quite hard to understand what the person's saying. So not only is splatter bad because you interfere with other stations, it also reduces the intelligibility of your transmission quite a bit. So now that we know what splatter is, what it looks like, what it sounds like, and why it's bad, what are the common causes of splatter? Well, we're going to look at least 2 fairly common causes of splatter. And then we're going to look at how you can use a tool in your own radio to avoid inducing splatter. So let's go back to the computer and let's talk about what causes splatter. In order to understand what causes splatter, we have to first get a basic concept in our heads. And this will be old news to those of you that study electronics and have been messing with electronics for a while, but for the new hams, we have to understand a basic principle of amplifiers. Now, amplifiers are used all throughout your radios. They're used to, of course, amplify signals. They're used to control the gain of signals, the volume of signals. They're used in filters and everything. The basic idea of an amplifier is a small signal goes in and a big signal comes out. They amplify. No kidding, really? Well, yeah. The thing, though, that's important to understand is that all amplifiers have a hard limit. There's a point beyond which they cannot amplify a signal any further. This might be due to the power supply voltage that's feeding the amplifier. For example, in a voltage amplifier, if you only had a 12-volt power supply source, it's not going to be able to produce an output signal that's greater than 12 volts because it doesn't have the headroom to push that signal up into. It has a limit. Regardless of the amplifier's design or style or what type it is, every amplifier is going to have a physical hard limit beyond which it cannot amplify. And what happens is if you push this small signal that's coming in, if you push that up a little high or too high, and the amplifier tries to amplify beyond that limit, you'll get what's called clipping, where the signal would try to extend beyond that limit, and it'll end up flat topping and just clipping off that top part of the signal, as you see here and here and here and there. The problem that this causes is where this clip occurs, you're going to have harmonics created. It's kind of like with a square wave. When the voltage that's coming up smoothly suddenly transitions, that sharp edge to that transition is going to cause harmonics and distortion and noise and garbage signals that are going to go flying down wherever this amplifier is feeding. And those distorted signals are going to cause things like, well, what we saw was the splatter. Now, this presents a problem in radio because our voice is very dynamic. The human voice goes from low volume levels to very high volume levels just as we're speaking. So an amplifier either has to have an extremely broad range, or you have to do something to bring the lower levels of the voice up without amplifying the higher levels of the voice. And the circuit that was created to handle that, well, let's first off, let's look at a very simplified block diagram of a transmitter, okay? So this is extremely simplified, but it gets the idea across. Your audio source, your microphone over here, feeds into a section that does a little preamplification because the signals from a mic are very, very tiny. Filtering, equalization, and the preamp section of this will usually be controlled by your mic gain control, right? That's how you control how much oomph and push you're getting out of that microphone. Optionally, there might be a compressor in line there, which would compress the dynamic range of the voice, amplifying the lower level parts of the voice without amplifying the upper level, compressing that dynamic range down. It can give audio a little more punch, but it can also overdo things as well and contribute to the problem. The audio then would come into the modulator section of the radio, and this is where the audio that's coming in gets modulated onto the RF coming from the radio's VFO and produces the modulated RF that then goes to your power amp and eventually out your antenna. So that's basically how a transmitter works. That modulator section will have a little preamplifier that processes and amplifies that audio to drive the modulator itself. And that's important because the tool that I mentioned, and it's the addition to modern radios, is something called an ALC, which stands for automatic level control. Now what the ALC does is it monitors the signal level that's being fed in to the modulator, and it produces a control voltage that adjusts the gain of this preamplifier. And what the ALC is going to do is, if a very strong peak in audio is coming in, it's going to pull back that amplifier gain and allow that strong peak to come in below that hard limit so it doesn't overwhelm the modulator. And then when the lower level audio is coming in, where you're speaking more quietly, that control voltage again will reduce or change to bring the gain of this preamplifier back up. So this kind of smooths things out so that our dynamic voice that's going really loud to really soft to really loud kind of smooths out to a more average level into the modulator to produce a clean modulated RF signal coming out. So the common causes of splatter are firstly turning the mic gain up too high. You're creating too high of a voltage signal coming in, and that signal will overwhelm this ALC. The ALC, kind of like other amplifiers, is going to have a hard limit. It can only do so much. There is only so far that it can pull this preamplifier back. You can still overwhelm it by driving it too hard, and those high-level signals will come through and clip and cause the garbage and the splatter. The other area that you can induce splatter with is the compressor. The compressor can be overwhelmed, and if you're driving it too hard and then you turn its gain up too high, then that increases the problem. So there's two areas in the radio where you can cause splatter. Too high of a mic gain and too much compression. The second most common cause of splatter is when you're using a linear amplifier and you drive too much power from your radio to the linear amplifier, overloading or hitting that hard limit in the linear amplifier, which it has as well as just any other amplifier. Most linear amplifiers will also have an ALC function, either built in or using an ALC control voltage from the radio, so you have adjustments there. And where do you adjust that ALC to cut back on splatter? On my ICOM 705, if I go into the metering function, we can see that there's an ALC meter right here. Now I've presently got it hooked up to my dummy load, so I won't be interfering with anybody. What I'm going to do is I'm going to transmit, and I'm going to show you, well, first off, let's go in here to mic gain. And I'm going to turn the mic gain up too high. Okay, we'll set it to 82% here, which is, I know it's going to be too high. Watch that ALC meter when I transmit. KB9 RLW testing, 1, 2, 3, 1, 2, 3. Now, as you can see, it got right up to the very top of the meter. That means I'm probably overdriving, probably clipping, and probably splattering. I'm pushing the ALC beyond its range, beyond its ability to pull that gain back. Let's make it even worse. I'll put the mic gain all the way up to 100%. KB9 RLW testing, 1, 2, 3, 1, 2, 3. And you could see that it hit that top edge and that little red bar appeared right there, telling me that I've exceeded the ALC's range. So that's not good. I'm pushing things too hard, and if I talk too loud, like let's say I laughed at something, oh yeah, that was a funny joke, ha 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 ha, you can see that it was just slamming there at the top. That's bad. I'm pushing the ALC too hard, it can't pull the gain back far enough, and I'm probably clipping, almost certainly clipping, and that would be causing splatter and distortion. The other thing I could do to make it worse would be if I turn down the compressor, and I turn the compressor up. KB9 RLW test, 1, 2, 3, 1, 2, 3, 1, 2, 3. There you go. You can see that that meter stayed all the way at the top. I'm way overdriving. That signal would have been dirty and nasty on the air, splattering all over the place. So we'll turn the compressor off. I'm going to pull the mic gain back down where I like to keep it, and I found this by experimenting, but what you want to do is you want to find where your normal speaking voice is going to keep that ALC action in the lower half of its range. There might occasionally be a peak up into the upper part, but what we're doing is we're giving it headroom. We're giving it extra space to work if we happen to suddenly speak more loudly. So I've got my mic gain at 45%, and now I'll transmit. KB9 RLW. I'm still a little bit hot. See, I'm still hanging out there at the top. 1, 2, 3, 1, 2, 3. Yeah, I'm still a little too high. Let's back that down. Let's try 35%. KB9 RLW test. 1, 2, 3, 1, 2, 3, 1, 2, 3. And the lower speaking voice. I'm tickling a little. Maybe just a little bit more. What you really want is you want to reach a point where your normal speaking voice is just tickling the meter, so you're just getting into the ALC action, and a little bit louder speaking is wiggling it around in that lower half of the range. Let's see how we are now. KB9 RLW testing. 1, 2, 3, 1, 2, 3. Okay, that looks pretty good. You're going to have some ALC because the human voice is very dynamic.
So there you go. I hope you found that information useful. And I certainly hope that you care enough about your signal to put it into practice, because splatter is a very annoying, interfering thing. And one example is this last weekend was JOTA, Jamboree on the Air. It's a Boy Scout event where Boy Scout troops meet up with hams and get on the ham radio and get exposed to ham radio. And that was my first experience with ham radio when I was a kid. Was going out to the local amateur radio club's field day site and participating in that. And that's actually what lit the fire under me for radio, got me interested in it. And this last weekend, I was going to make a bunch of contacts with JOTA and do a video about the history of it. Well, what happened was
the New York QSO party was going on, and 20 meters, for an example, was very, very crowded. And I found a couple of JOTA stations, but they were having a hard time. There were stations on either side of them that were splattering out to 6 kilohertz. And the poor scouts, they kept on saying, I don't understand. What did you say? I couldn't hear you. Too much noise. You know, I mean, they had what was undoubtedly a bad first experience with ham radio because of all the interference from these adjoining stations that were putting out these garbage and nasty signals. I mean, they were just nasty and distorted. And even if you turned over and listened to them, which I think I probably showed you in the demo, it hurt their understandability, the quality of their voice. They were so distorted and garbled that it was hard to understand what they were saying, even if you were trying to talk to them. So splatter not only interferes with people that are beside you, but it also greatly affects the quality of your signal and the clarity of your voice, and it can actually hamper communications. The difference is profound. When you adjust that ALC right and you're not splattering, single sideband can sound almost as clear as AM. It's very, very easy to understand the voice, and it can be very clear communications if your radio is adjusted properly. So, hope you found that useful, and we'll see you in the next video. Thanks for watching. If you enjoyed the video, don't forget to give it a thumbs up. Also, if you're not already a subscriber, click to subscribe. Join us on the Facebook channel for discussion about the videos. And if you'd like to help support this channel, please click to support me on my Patreon page.